Alright, ProPilot 1 class. This is just a quick video using Gyronimo performance software to talk about takeoff performance, maybe even climb performance and landing performance. To just further clarify and maybe concrete some of these concepts that we've talked about. This is an app you can get for many different airplanes, but this particular one is set up for a Diamond DA40. We can't use it for actual performance, but it's a wonderful tool to teach you how these different variables impact performance. So I believe back in our weight and balance lecture I talked about how you can put these weights in and how it spits out CG and total weights, and it's a very usable, wonderful little tool, but it also does takeoff, which is what we've talked about here recently. So it will do a takeoff simulation. I'll just show you the left side of the chart here, and then it's got all these variables starting with aircraft mass, aka weight, elevation of the airport, temperature. Then we can even put our altimeter setting in. I don't know why that was set down there at the minimum, but we can see here based on all these different variables how our takeoff distance is affected. And this is also a very good illustration of our ground roll versus our distance over a 50-foot obstacle, shown on the top, and the yellow showing the ground roll and the red distance showing the distance over a 50-foot obstacle. So we're going to manipulate some of these variables just to show you how this is going to impact different things. Notice on the bottom it's got the winds, and I had a headwind in there. I'm going to take it to 0. And notice as I did that, what happened to the takeoff distance. So we're just going to note the relationship of these variables to takeoff distance. So the first one will be pretty logical. The aircraft mass, or the weight, is showing 2,313 pounds. What do you think the distance is going to do as weight increases? Well, the heavier we are, the slower we're going to accelerate, and also it's going to suffer in terms of climb performance initially. So as we get heavier and heavier, our distance increases up to our maximum gross weight. So that makes sense. Then again, as we get lighter and lighter, those distances decrease. So that's just an easy way to visualize that. What do you think about in terms of takeoff elevation? Well, the air's density decreases the higher we go. So the higher our airport, the longer our takeoff distance is going to be. So currently it's set to 1,100 feet. Let's say we took off at a really high airport. Obviously it's going to increase. So we get up there to 3,000, 4,000, 5,000 feet, and obviously that takeoff distance is increased as a result. Then we've got temperature. So this was a question, well, we talked about this on the D2L quiz. Notice it says ISA, and it gives a deviation for temperature. So it would say ISA, if we wanted to set ISA, then that could work. I guess we could test this. Yeah, so as the airport elevation changes, that ISA temp changes, as you see here, because ISA has values all the way up from sea level up through 50, 60,000 feet. Anyway, let's just manipulate the temperature and say on any given day, obviously the temperature is going to increase throughout the afternoon, and then into the night it's going to decrease again due to changes in diurnal changes. But the hotter it gets, the greater that takeoff distance. And then as the sun sets and the air cools, it'll cool back down, and that takeoff distance will decrease as well. Lastly, altimeter. Ideally, we want high pressure. High pressure thus reduces density altitude and increases our performance. Another thing this little app does is it actually shows a density altitude as well based upon our altimeter setting and our temp. So let's take pressure and make it high, or increase it a little bit. As pressure increases to 30, which is pretty high pressure, you do see a very slight decrease in these values, and also a slight decrease in density altitude. So higher pressure is ideal for performance, whereas lower pressure is less ideal. And variations in pressure do impact both density, altitude, and our takeoff distance, but to a lesser extent than the temperature variations. So temperature and pressure play a role in this, but the temperature variations play a bigger role and have a bigger impact than do those variations on our pressure. Sorry about that. Lastly, one thing we can look at down here is runway conditions. We can say we're on grass. What do you think it's going to do if I say we're taking off not on pavement, but on grass? Obviously, it's going to significantly impact that distance due to the greater friction, the slower acceleration. And then lastly, winds. With no wind, that's our distance. If we get a headwind, that's going to help us out. And if we get a tailwind, obviously, that's going to not help us. It's going to increase our distances. So this is a nice little tool just to show you guys how some of this stuff works. It does have a climb chart where it shows a lot of things, but basically it'll give us climb rates based on these different factors as well. And then it's got a landing, it's got cruise and landing as well. And this for landing, showing the landing distance over a 50-foot obstacle being that red line, and then the landing ground roll being the yellow one there. So just wanted to take an opportunity to use this software and to show that to you guys pretty briefly. I'll get the iPad back out in a couple weeks, and I encourage you guys to download this app for VORs. It's called Radio Nav Sim, and when we get to the VOR lecture, I really have a hard time teaching it without this app, so I'll probably do that lecture just all here on this app, and hopefully that'll help.